Hello coders, I welcome you all. In this video, we are going to create a complete MLOps project. Specifically, we are going to build a water potability prediction system using machine learning. After this project, you will understand how end-to-end machine learning projects with MLOps are created in the industry, and you will gain insight into this process. Now let me explain how to approach this video. In your first viewing, just watch the entire video. In the second viewing, try to follow along with me. You can also access my code on GitHub. And you can see this is the project flow we will discuss step by step. Our project is defined as water potability prediction using machine learning. This is our problem statement. First, in this project, we will prepare different experiments. After that, we will identify the best experiment with best hyperparameters, meaning the best model. And here you can see we will log everything, including the experiments using MLflow on desktop. So once we find the best model with best hyperparameters, we will create a DVC pipeline and register that model in the MLflow model registry. At the end, we will also build an application by fetching the model from the model registry, which is available on desktop. So let's get started. I have divided this video into 4 sections that you can see over here. In the first section, we will handle setup related activities for our project. In the second section, we will plan some experiments. In the third section, we will create a DVC pipeline for the best experiment or best model that we found in the section 2 during our experiments. Finally, in the fourth section, we will register our best model in the MLflow model registry, which is available on desktop, and build the application for our project. So let's begin with section 1, where we will handle the setup related activities for our project. First, we will download cookie cutter template to our machine so that we don't need to worry about how the project structure should look or other details. So let's start with our section 1, this one, where we will handle the setup related activities for our project. So let's open command prompt. And first we need to install cookie cutter using following command: pip install cookie cutter. Let's press enter. You can see in my case requirements are already satisfied because I have already installed cookie cutter on my computer. So now let's download the cookie cutter template first. Let's clear this. To download the cookie cutter template, we have to write following command: cookie cutter -c v1 https://github.com/revun-data/cookie cutter -data-science. Let's press enter. So here you can see at first it will ask if you want to re-download cookie cutter template. Let's press yes. Now project name. Let's give MLOps_project. You can give any other name as well. Repo name. Let's provide same name. MLOps_project. Author name. Data thinkers. Description: water potability prediction using ML. Let's press enter. Here we are selecting no license. Let's skip this particular step. S3 bucket. Also, we are not going to create any AWS profile at this time. So let's press enter. And here we are going to select Python interpreter as Python 3. So here I am choosing 1. Now done. Now that everything is done, we need to move inside the project directory. This one. So let's copy this and let's move inside our project directory. And let's open VS Code in this directory by following command code space dot. Let's press enter. You can see various folders and files designed to manage our machine learning project that you can see over here. These all files and folders are provided by our cookie cutter template that you can see over here. So now let's remove unnecessary files from the current project structure. So let's move inside SRC folder. Let's remove this unnecessary files because we are going to create them from scratch. Let's remove this. Also, let's remove this from the model folder. Let's delete this. Also, let's delete these Python files which are provided by cookie cutter template. But as I said, we are going to create these files from scratch. That's why we are deleting all these files which are defaultly provided by cookie cutter template. Now done. Also we have to do one thing. Let's rename this folder from models to model. Now all done. Now let's create a virtual environment first. So let's click on terminal and new terminal. So to create virtual environment, we have to write following command: python -m vnv my env. Let's press enter. After that, we have to activate this particular environment. To activate this particular environment, we have to change execution policy by using following command. After you are done working with your virtual environment, you can set the execution policy back to its original state. For security reasons, in place of this bypass, you have to use the word restricted to set the execution policy back to its original state for the security reasons. So now let's activate our created environment my-env/scripts/activate. Let's press enter. You can see our virtual environment has been activated, that you can see over here. Now let's use following command pip list to check how many dependencies are installed in our current environment. Only two: pip and setup tools. So first let's initialize git. Here you can see this particular file .git ignore. This file helps manage which files and directories Git should ignore in your project. So here we can specify the files and folders that we don't want to track. So let's click on this file, and we don't want to track my env. Let's save this file. You can see color of this folder has been changed to white, that you can see over here. Let's clear this. Let's check git status. You can see this many untracked files. Again, let's clear this. Let's add all the files to the staging area. Let's commit this changes. Add cookie cutter template. Let's press enter. Now done. Let's clear this. So now let's move on. Here we are going to create a repository on GitHub online, right? So let's move to GitHub, and here I'm going to create new repository MLOps_project. You can use any other name as well. I am keeping other things as it is. And let's press this button, create repository. Let's copy this URL and let's move back to VS Code. And here we have to add our created remote repository using following command: git remote add origin and this URL for our created repository. Let's press enter. So here we have connected our local Git repository to the remote repository available on GitHub that just we have created, this one. Now let's push our code to GitHub. So for that we have to write following command: git push origin master. Let's press enter. Now done. Let's check on GitHub. Let's reload this page. You can see over here our cookie cutter template now available on GitHub, that you can see over here. So what we have completed so far? So as you can see here, we have just downloaded the cookie cutter template, set up GitHub and pushed our code to GitHub, that you can see over here. Now let's move on. We are going to set up MLflow on desktop. So as you can see, currently I am using desktop.com. Let's press login. As you can see, we can sign in using GitHub, Google, or by creating an account. But I will be logged in with GitHub. So let's press this button, continue with GitHub. So you can see that we have successfully logged in to desktop using GitHub. So now our next step, let's connect our GitHub repository with desktop. So here we have to press this particular button, create, and here we have to press new repository. So as you can see here, we have three options: create blank repository, create from template, and connect a repository. Since we have a repository, so let's press connect a repository. Again, two options. We can connect from GitHub, Bitbucket, GitLab, or other platforms. Since we have created the repository on GitHub, let's connect using GitHub. So here I have to enter my GitHub password. Now done. You can see different permissions. Read access to metadata, read and write access to code, issues and pull requests. Now here we have to select this option. Only select repositories. Let's click on this and here we have to search our repository that just we have created, this one, and let's remove the previous one. Let's press this particular button, save. Let's click over here and here we have to press this particular button, connect repository, and let's press no, thank you. So you can see that the interface of DAXUP is very similar to GitHub. DAXUP is used in data science, so you can see these tabs like files, datasets, experiments, models, collaboration and annotations. Now let's click on remote and then experiments. So you can see that it provides a link and code to connect with DAXUP. Let's copy this information and store it somewhere because we require this information to connect our code with DAXUP. So let's copy this. Let's open Notepad. Let's paste this link over here. Let's copy this code and let's paste it over here. And let's open MLflow UI by clicking over here. You can see the MLflow UI. We are going to log everything here on DAXUP using MLflow. So when we perform different experiments, we can see the result of each experiments over here in this particular UI of MLflow, which is available on DAXUP. Now let's move to VS Code. So you can see that currently we are inside our virtual environment, which is separate from the base environment. So we need to install the required dependencies. So first we have to install MLflow using following command, pip install MLflow. So we have to wait. It will take some time. Now done. Let's clear this and let's install DAXUP. Before that, we have to use following command, pip install DAXUP. Let's press enter. Again, we have to wait. It will take some time. Now done. So we have successfully installed MLflow and DAXUP. Let's clear this and also we have to install Seaborn. Let's press enter. Now done. Let's clear this and also we have to install XG Boost. Now done. So you can see we have successfully installed our required libraries, MLflow, DAXUP, Seaborn and XG Boost. Now let's move on. So as you can see, we have stored the connection related information in Notepad. Now let's perform a test to see if we are able to log the experiment or not. Means we are going to do this just to test the connection with DAXUP and we are going to log this dummy parameters. In short, we are going to use this example script just for testing. So let's create new Python file inside this notebooks folder with name DAXUP_test.py. So let's import MLflow. Also we have to import DAXUP and let's use this code that we have taken from DAXUP. Also we have to set our tracking URI, this one. Again, as you know, we have taken all this information from DAXUP. Let's save this file. Let's clear this and let's run this file. Let's right click over here and copy path. Let's paste it over here. Let's press enter. Now done. Let's check over here. Let's reload this page. You can see over here. We have successfully logged this dummy parameters on DAXUP that you can see over here. Parameter name value, metric name 1. These are dummy parameters that just we have used for testing purpose to test connection with DAXUP. So now here we have completed our section 1, which means we have finished the setup related activities for our project. Now let's move to our section 2, experiments. As you can see here, we can plan experiments in many ways. In this project, we will first use a baseline model for our first experiment that you can see over here. This is our first experiment where we are going to use a baseline model. A baseline means a simple model with default parameter settings. In the second experiment, we will fill in the missing values using the median and test various classifiers that you can see over here. In our third experiment, we will fill in the missing values with the mean instead of the median and try different classifiers again. Now in the fourth experiment, we will use the best imputation method, either mean or median, that we identified during these experiments that we have performed over here. And also we will perform hyperparameter tuning for the best model identified during these experiments. So let's get started. Let's jump to VS Code. We can perform these experiments in the Jupyter notebook as well, but we are going to perform them in VS Code. So now let's perform our first experiment where we are going to use a simple baseline model of random forest classifier. I have randomly selected random forest classifier for our first experiment, but you can choose any other classifier as well. To save recording time, I have already written the code for the experiments, and we are going to create our different experiments in this particular folder, notebooks. So let's click over here and let's create new Python file with name exp1.py, and let's select this code. So as I said, to save recording time, I have already written the code for the experiments. Let's copy this code and let's paste it over here. Let's save our file. So just we have to change this information in our experiment 1. So this information that we have taken from desktop, let's copy this tracking URI and let's paste it over here. Let's copy this init statement and let's paste it over here. Let's save our file. And here we have already set experiment with name experiment 1. So before we execute our experiment 1, let's visit this code once. So here we are importing necessary libraries, and here we initialize desktop and set up MLflow experiment tracking. Here we are loading our data set. Here we are splitting our data set into training and test sets. Here we are keeping 80% data in training and 20% data in testing. And here we define a function to fill missing values in the data set with median value of each column that you can see over here. This is our function to fill missing values in the data set with the median value of each column. Here we are filling missing values in both the training and test data sets using median, means using this function. Here we are importing our baseline model, random forest classifier, and pickle for model saving. Now let's move on. Here we have separated features and target for training. And here we are setting n estimators, means number of trees in the random forest classifier with its default value 100. And here we are starting a new MLflow run for tracking the experiment. Here we initialize and train our random forest classifier with default estimators 100. This one. And here we are saving the train model to a file using pickle with this name model.pkl. And here we are preparing our test data for prediction that you can see over here. And here we are importing necessary metrics for evaluation, accuracy, precision, recall, and F1 score. And here we are loading the saved model for prediction that we have saved over here. This one. And here we are performing prediction on the test data using this saved model. And here we are calculating performance metrics, accuracy, precision, recall, and F1 score for our test data that you can see over here. Y test and Y pred, actual values and predicted values. And now here we are logging metrics to MLflow for tracking, accuracy, precision, recall, and F1 score that we have calculated over here, that we are logging to MLflow for tracking. Here we are logging the number of estimators used as a parameter, and estimators. As you know that we have set 200, right? Now here we are generating confusion matrix, and here we save the confusion matrix plot as PNG file. And here we are logging the confusion matrix image to MLflow as artifact that you can see over here. Here we are logging the train model to MLflow, our random forest classifier, right? And here we are logging the source code file for reference, this particular file, exp1.py. And here we are setting tags in MLflow to store additional metadata. And here we are printing performance metrics on the console. So this is our experiment 1 that we have discussed over here. Baseline model, right? Now let's click over here. Let's copy path and let's execute our experiment 1. So this is our experiment 1, our first experiment where we are running baseline model of random forest classifier, right? Let's execute our experiment 1. We have to wait, it will take some time. You can see PNG file for our confusion matrix has been created. Now done. You can see over here accuracy, precision, recall and F1 score that we have printed over here, right? Now let's move to desktop. Let's reload this page and you can see our experiment 1. Let's click over here. You can see our run ID and each and every information. You can see parameter and estimators with default value 100. And you can see precision, F1 score, accuracy and recall. So we can say that we have successfully executed our experiment 1, our first experiment with the baseline model of random forest classifier that you can see over here. And also you can see that we are achieving this level of accuracy, precision, recall and F1 score. So we can say that we need to maintain at least this level of performance or aim to achieve even more, right? So this is our baseline model and we have achieved this level of accuracy, precision, recall and F1 score. Let's move to model metrics that you can see over here. Precision, F1 score, accuracy around 67% that you can see here, and recall. Let's check artifacts. As you can see, everything that we have logged through the code is available here. You can see our source file, confusion matrix, requirements.txt, YAML file has been created, our saved model, this conda.yaml has been created, and this ML model file has been created by MLflow that you can see over here. So we have successfully executed our experiment 1 and we have achieved this, right? So as I said, we have to maintain at least this level of performance or aim to achieve even more. So now let's move to our second experiment. So now let's move to VS Code. Let's click over here, notebooks folder, and let's create new file, exp2.py. For our second experiment, let's select this code, let's copy this code, and let's paste it over here, experiment 2, and again we have to change this for MLflow tracking. Let's copy this, let's paste it over here, let's copy this tracking URI, and let's paste it over here. Let's save our code. So let's visit our code. Again, here we are inputting necessary libraries. Here we initialize desktop and set the experiment for MLflow tracking that you can see here. Our experiment 2. Our second experiment. Here we are loading the data from CSV file and split into training and testing sets that you can see over here. And now here we define a function to fill missing values with the median value of each column that you can see over here. And here we pre-process training and testing data to fill missing values by this function using median of the respective columns. And here we are splitting the data into features and target for training and testing that you can see here. And here we define multiple baseline models to compare their performance that we have already discussed over here, right? So we have completed this first experiment. Now we are here on our second experiment, filling missing values using the median. And here we are trying this many classifiers, right? After that, we will move to our third experiment where we are going to fill the missing values using the means average. And we will try again this many classifiers, right? Currently we are here. Let's move to VS Code. And here we start a parent MLflow run to track the overall experiment. So this is our parent run and this is our child run. So here we iterate over each model in the dictionary, this dictionary. And here we start a child run within the parent run for each individual model that we have listed over here. Here we train the model on the training data that you can see over here, X train and Y train. Here we save the train model using pickle that you can see over here. Here we are making prediction on test data. Here we are calculating performance metrics that you can see here: accuracy, precision, recall, and F1 score for each models that you can see over here. And here we are logging the calculated metrics to MLflow: accuracy, precision, recall, and F1 score that we have calculated over here, right? Again, here we are generating confusion metrics for each and every classifiers that we have defined over here, right? And here we log the confusion matrix plot as an artifact in MLflow for each and every classifiers, right? And here we log the model to MLflow, each and every models. And here we are logging the source code file, this file, exp2.py. And here we set tags for the run to provide additional metadata. And finally, we are printing this message. So this is our experiment 2. So as we discussed earlier, in the second experiment, we will fill in the missing values using the median of the respective column that you can see over here. And we test various classifiers, right? So this is our second experiment. Now let's clear this. Let's copy path and let's execute our experiment 2. Again, we have to wait. It will take some time. So in experiment 1, we used only one baseline model, the random forest classifier. However, in this case, in our experiment 2, in our second experiment, we are using multiple baseline models to find the best one for this dataset, right? And also, we filled the missing values with the median of the respective column, right? In our second experiment, please remember this. So we are here filling missing values using the median, and we are trying this many classifiers, right? Now almost done. Still we have to wait. Now done. Let's check on desktop. Let's reload this page and you can see our experiment 2. This is our parent run. Let's click over here, this plus sign, and you can see our different classifiers. Let's click over here and let's click on chart. You can see over here accuracy, F1 score, precision, and recall. So we have achieved around 69% accuracy in our experiment 2, right? And this is F1 score for random forest classifier, and we have achieved around 69% accuracy, which is highest for random forest classifier that you can see. Same for F1 score, precision, and recall as well, right? For random forest classifier, recall is somewhat less compared to others, but accuracy, F1 score, and precision are more compared to others, right? Okay, so we can say we have successfully executed our experiment 2, and you can see we are achieving this level of accuracy, precision, recall, and F1 score in our second experiment. You can see by looking this, we can say that random forest classifier is the best model for this dataset, right? As per our experiment 2. So now let's perform one more experiment, experiment 3. Our third experiment. So let's jump to VS Code. So let's click on this folder notebooks. Let's create new file exp3.py. Let's click over here. Let's select this code. Let's copy this code and let's paste this code over here. Let's save our file. And again here, let's copy this line, paste it over here. Let's copy this tracking URI and let's paste it over here. And our experiment 3, let's save this file. So again, here we are going to use different classification models that you can see over here. Logistic regression, random forest classifier, support vector classifier, decision tree classifier, k nearest neighbors classifier, and XGBoost classifier that we have used in our experiment 2 as well, right? Same classifiers we are using here in our experiment 3, our third experiment. But here we are filling missing values with mean, means average, in place of median that we have used in our experiment 2, right? Here in experiment 2, we have filled missing values with median. But here we are filling missing values with means average value of the respective columns that you can see over here. Otherwise, entire code is exactly same that you can see over here, right? As experiment 2, same code that we are using here. As I said, only the change is here. We are filling the missing values with mean in place of median, right? Okay, let's clear this, copy path, and let's execute our experiment 3. Here again we have to wait, it will take some time. So please remember, here we are filling the missing values with mean in place of median, right? In our experiment 3. So you can see this is the simple technique I am following for the experiment. But you can plan many such experiments as per your project, right? Now done. Let's check on desktop. Let's reload this page and you can see here our experiment 3. This is parent run and child runs. Let's select this all and chart. Again here we are achieving highest accuracy for random forest, 69%. Check in experiment 2. Here you can see 0.685, 68.5. Let's click on experiment 3 and here 69.2, right? And let's check one more time. Click over here and chart. And here 68.5 and here 69.2, right? So you can see the changes in the result with this very simple experiment. The accuracy has improved, right? So now you can understand the importance of planning various experiments, right? So here in this experiment, experiment 3, accuracy is higher compared to our previous experiment. Experiment 2, right? Here we filled missing values with mean, right? And here in experiment 2, we filled the missing values with median that you can see over here. Now you can see from these different experiments, we can see that the random forest classifier is the best model for this dataset, right? So let's move forward with it and let's perform hyperparameter tuning in our next experiment, our experiment 4. And also don't forget to fill the missing values with the mean because we got somewhat good results with it that you can see here, right? So you can see in our third experiment, we filled the missing values with mean. And with this simple change, our accuracy has improved, right? So you can understand that the importance of experiments, right? That you can see. Okay, let's move on to our experiment 4, where we are going to perform hyperparameter tuning because we want to find the best parameter for our best model, random forest classifier, right? So now let's move on. So now let's move to VS Code. Let's click on this folder notebooks. Let's create new experiment, experiment 4.5. Let's select this code. Let's copy this code. Let's paste it over here. Again, we have to change. This is our experiment 4 and here let's copy this. Let's paste it over here. Let's copy this tracking URI and let's paste it over here. Let's save our code. So this is our experiment 4. Again, here we are importing necessary libraries. Here we initialize DexServe for experiment tracking. Here we set the name of our experiment, experiment 4. Here we are setting the tracking URI for MLflow to log the experiment in DexServe, right? Here we are loading our data set. Here we are splitting our data set into the training and the test sets with 80-20 split, right? And here we are filling the missing values with the mean of each column that you can see. And here we apply the function to fill missing values in both training and test sets using this function, right? And here we prepare the training data by separating features and target variable. And here we define random forest classifier model and the parameter distribution for hyperparameter tuning that you can see. Our parameter distribution. Here we are using two parameters, n estimators and max depth of random forest classifier with these different values. 5 values for n estimators and 5 values for max depth. Total 5 into 5, 25 combinations that we are trying, right? And here we are performing randomized search CV to find the best hyperparameters for the random forest classifier. And here we are running parent and child run that you can see. Parent run and child run here to find the best combination of these parameters, n estimators and max depth, right? And here we log the parameters and mean test scores for each combination we tried. So here we are checking each combination of hyperparameters that you can see and their corresponding matrix values. We log all the combinations. That's what we are doing here. If we are not using here parent and child run, it will create multiple runs, and with more runs, it will fill up this entire window, right? Which we don't want. So that's why we create runs based on the parent and child combinations that you can see. In short, we are going to perform a nested run, a run inside run. In our case, as I said, n estimators has 5 possible values, right? And max depth has 5 possible values. So total number of possible combinations is 5 cross 5 is equal to 25 possible combinations, right? So this means that 25 distinct hyperparameter combinations can be explored using randomized search CV using this nested loop, right? And here also we are logging each and every combinations using MLflow on desktop. So let's clear this, copy path, and let's run our experiment 4. Again, we have to wait. It will take some time. As you can see, fitting 5 folds for each of 25 candidates, right? You can see. So as I said, it will take some time. We have to wait. But look at here. Here we are trying each and every combinations that you can see for max depth and n estimators to find the best parameters values for n estimators and max depth of random forest classifier. Please wait, almost done. You can see best parameters found, n estimators 1000 and max depth none, right? Which is default. But you can see n estimators 1000 and you can see accuracy, precision, recall and F1 score. Let's check on desktop. Let's reload this page and this is our experiment 4. You can see parent run. And here we are logging dataset as well inside this parent run that you can see and our 25 combinations that we have logged over here, right? Let's click over here and you can see n estimators 1000, max depth none. This is our best parameters with these values 1000 and none. And you can see and corresponding accuracy, precision, recall and F1 score that you can see over here. And you can see, as I said, we are also logging dataset as well for our best experiment, right? You can see model metrics and let's move to artifacts. You can see over here ML. Also we are logging the script as well. You can see. Let's back and done. So you can see our base parameters for the random forest classifier with their best values along with its accuracy, precision, recall and F1 score, right? So far we have achieved the following from the different experiments. We have determined that the mean is a better technique for filling missing values compared to the median, right? Additionally, we have found our best model, random forest classifier. And finally, in our experiment 4, where we have performed hyperparameter tuning and we found base parameters with their corresponding values 1000 and none for n estimators and max depth, right? Now all done. In short, we have completed our section 2 experiments. Now let's move to section 3 where we are going to create the DVC pipeline. Hope all of you are clear with this. So now let's move on. So before we create the DVC pipeline, let's push our code to GitHub. Let's add all the files to the staging area. Let's commit the changes, add experiments 1 to 4, all done. Let's push our code to GitHub. Now done. Let's clear this. So as you can see, we have achieved these results after our experiments. We found our best model along with the best imputation technique for filling missing values, the random forest classifier and means average imputation, right? After hyperparameter tuning, we also found the best possible values for our hyperparameters, n estimators and max depth, right? 1000 and none. Now we are going to create a DVC pipeline with our best model so we can execute our entire experiment with just one command. The DVC pipeline is easy to maintain and scalable as well. That's why with our best model, we are going to create DVC pipeline. So let's jump to VS Code and let's build our DVC pipeline. So first we have to initialize DVC using DVC init command. You can see we have successfully initialized DVC. Let's clear this. Please remember, we are going to use a local disk for data storage, which means we will handle data versioning to maintain different versions of our data. Our data will be stored in a temp folder on our system, on our local computer, right? So for that, we have to write following command: DVC remote add -d. Here, this particular flag -d specifies the default storage. This means you can create multiple storage locations if needed, right? And let's give name to our remote, my remote. Let's open our temp folder. And let's copy this path and let's paste it over here. Slash, let's create new folder with name DVC inside this particular folder, temp folder, right? Let's press enter. You can see we have successfully added remote storage that you can see over here. So as you can see, we have initialized DVC and set up local storage to store different versions of our data. Please remember, instead of local storage, we could use AWS or Google Drive as well. But for simplicity, I am using local storage in our temporary folder, means in our temp folder. So now let's move on and let's add the different stages of our pipeline. So the code is exactly same as we have been using since long, except I have added MLflow tracking in the model evaluation module, nothing else, right? The other modules remain unchanged. You can find all of this in my GitHub repo. So as you know, we have 4 stages in our pipeline: data collection, data pre-processing, model building, and model evaluation. So let's create the stages for our pipeline. We will start by adding our first stage, data collection. So let's move to this SRC folder and let's right click on this data folder. Let's create new Python file with name data_collection.py. Let's select this code. Let's copy this code and let's paste it over here. As I said, the code is exactly same as we have been using since long, right? So now let's move on to our second stage, data pre-processing. Again, let's right click on this data folder. Let's create new file with name data_prep.py. Again, let's select this code. Let's copy this code and let's paste the code over here. Let's save our file. And as you can see, we are filling missing values with mean, right? Instead of the median, because our experiments showed that the mean performs better than the median, right? So that's why here we are filling missing values with the mean of respective columns, right? So now let's move on to the model folder, this one, and let's create the third stage of our pipeline, model building. So let's right click over here and let's create new file with name model_building.py. Again, let's click over here. Let's select this code. Let's copy this code and let's paste the code over here. Let's save our file. So as you can see here, this stage contains our base model, the random forest classifier with the best parameter values that you can see over here. But as you can see here, we are fetching the parameter values from params.yaml that we will add shortly, right? So now let's move on and add our model evaluation stage. Again, let's right click over here. Let's create new file with name model_eval.py. Let's click over here. Let's select this code. Let's copy this code and let's paste the code over here. Let's save our file. So as I said, I have updated this code to include MLflow tracking in this module, right? That you can see over here. The remaining code is exactly same as we have been using since long, right? So now here we have to update the connection and tracking related information. This one that we can take from here. Let's copy this statement and let's paste it over here. Let's save our file. Again, let's copy this statement and let's paste it over here. Let's save our file. Now let's add the params.yaml file, which contains parameters such as test size from the data collection module and n estimators from the model building module. So first, let's right click over here and let's create new file with name params.yaml. Let's select this code. Let's copy this code and let's paste it over here. Let's save this file. So this is our params.yaml file. So as I said, this contains parameters such as test size from the data collection module and n estimators from the model building module that you can see over here. And let's set the value of n estimators to 1000, right? So as we found, this is the best value during our experiment for while hyperparameter tuning, right? So here we are not considering the max depth parameter because in random forest classifier, the default value is set to none, right? That also we found during our experiment for while hyperparameter tuning, right? So now let's add our main file dvc.yaml. So let's right click over here. Let's click on new file and let's create dvc.yaml. So as you can see our dvc.yaml file. So DVC will look into this file to execute our pipeline. So as you know, it contains the stages of our pipeline that you can see over here. Data collection, pre-processing, model building, and model evaluation. We can also add these stages like this directly here in dvc.yaml file. But if you recall, we have added this using commands, right? So let's select this code, let's copy this code and let's paste it over here and let's save our file. So now let's execute our created pipeline. Let's clear this. So to execute our pipeline, we have to use following command. DVC repro command. So DVC will run each and every stages which are listed here in dvc.yaml one by one that you can see over here. Currently we are at model building. Now we are at model evaluation and you can see we have set experiment name to DVC pipeline. It will take some time. We have to wait. I am going to pause this video. You can see that our DVC pipeline has been executed successfully. As we discussed, we are logging the results using MLflow on desktop from our model evaluation stage that you can see over here. Right? So let's check the logs on desktop. Let's reload this page. You can see over here, our experiment and run has been created. Let's click over here. You can see run ID for our created experiment. And here you can see we are logging parameters with their base values and their corresponding metrics, precision, accuracy, recall, and F1 score. Let's click over here, model metrics that you can see over here. Now let's click on artifacts. You can see here, our best model. You can see model.pkl, our confusion matrix for our best model. You can see matrix.json that we have created over here. You can see that also we have logged using MLflow on desktop that you can see over here, and our script that also we have logged that you can see over here. Our source code means this particular code. So now let's move on. So let's review our flow. So you can see we have completed all three sections: setup, experiments, and also we have created DVC pipeline. Right? As you can see, we have started with our problem statement, water potability prediction using machine learning. We performed various experiments, also found the best model, random forest classifier with optimal parameters values, right? And also built a DVC pipeline using this best model. So before we move on to the next step, our section 4 model registration, we want to store the run ID and model name of our best model in a JSON file so we can use them when needed. As you can see, currently we are in model evaluation stage of our created pipeline, and here we are logging our model using MLflow on desktop. You can see over here our log model that we have logged in model evaluation stage of our created pipeline. So as we just discussed, we are going to write a code to store this run ID and model name in a JSON file that we are going to write over here, model evaluation stage itself. So first, let's create one variable here as run with MLflow.startRun as run. This is our code. Here I have created Python dictionary and here I am fetching run ID, this one, for our best model. Using this variable means using this context. So here we are fetching our run ID and here is our model name, best model that we have logged over here. And please remember, currently we are in model evaluation stage of our created pipeline and we are storing this run ID and model name in this particular file inside this reports folder. And here we are creating this particular file with run_info.json in write mode. And here we are storing two values, run ID and best model, in this particular file. So this file will be created here in this particular folder, reports. In short, here we are fetching the run ID and model name, which we are storing in a file inside the reports folder with name run_info.json. Now let's execute our pipeline using the DVC repro command. Let's clear this and let's execute our pipeline. As you can see, DVC is skipping these stages: data collection, pre-processing and model building, because there are no any changes in these stages. Only running this particular stage because just we have changed this particular stage only, model evaluation, right? We have to wait, it will take some time. I am going to post this video. So you can see that our DVC pipeline has been executed successfully. Now let's check reports folder. And as you can see, run_info.json file has been created. Let's click over here. You can see it contains two values, run ID and model name. So now let's move on to our next step, model registration. So we have logged the model into MLflow here. And also we have stored the run ID and model name in the run_info.json file here, right? The reason we stored this information is that it helps us register the logged model in the MLflow model registry, as this information is required for the registration process of our model into MLflow model registry. Before we move to the practical part, let's first discuss regarding MLOps and the MLflow model registry. So I'm taking this example so you can understand the need of model registry. So as you know, we version the code using Git or GitHub, right? And version the data using DVC, data version control. Similarly, we can maintain versions of models using model registry. Hope all of you are clear with this. The need of model registry. We can maintain versions of models using a model registry, which is almost similar to GitHub and DVC. Hope all of you are clear with this. Now let's move on. So now let's first understand what is MLflow model registry. The MLflow model registry is like a library for your machine learning models. It helps you keep track of different versions of your models, know which ones are ready for use like in production, and even helps you switch between them when needed. Now the next question is, why use it? Imagine you have built a few models for predicting house prices. You want to keep track of which model performed best, which one is currently being used in your application, and you can easily swap out models if you find a better one. Now you can understand the need of model registry. The model registry helps you manage all this. The model registry serves as the midpoint between machine learning and ops operations. So now let's first discuss machine learning, this part. So data scientists and ML engineers focus on developing, training and tuning machine learning models. They experiment with different algorithms, hyperparameters and data processing techniques to create the best possible model. Now let's discuss model registry. Once a model is developed, it is registered in the MLflow model registry. This step marks the transition from experimentation to more controlled production ready environment. So you can see this is the midpoint. Now next, operations. So now assume that our model is available inside model registry. Now in the next step, the operations team can then take over developing the registered models into production environments. They manage the life cycle of these models, including scaling, monitoring, and updating them as needed. Hope all of you are clear with this. Let's move on. So if we talk about MLOps, MLOps is made up of machine learning and operations that you can see over here. Machine learning plus operations is equal to MLOps. Now let's first talk about model registry. The model registry serves as the midpoint between machine learning and operations that you can see over here. Machine learning, operations and midpoint is model registry. So before we start our session on model registry, let's first understand the workflow of how the ML model lifecycle typically works in the industry. This will help you to understand the need of model registry. As you can see here, different steps of ML model lifecycle: model development, model registration, model deployment, and monitoring and retraining. So let's start with model development. As you can see here, data scientists and ML engineers experiment with different models, hyperparameters, and the techniques to find the best possible model. They typically evaluate models with metrics like accuracy, precision, recall, and F1 score to choose the best performing model. Then the next stage will come, which is model registration. So once the best model is identified, it is registered in the model registry. The model registry serves as a centralized system to manage the versions of models, including metadata, stage transitions like model in the staging area, model in the production area, and model lineage. Don't you worry, we will discuss this all practically. Model lineage tracks model's journey from creation to deployment, indicating data sources, training, versions, and performance. It helps ensure transparency and reproducibility by documenting each stage of the model's lifecycle. So hope all of you are clear with two stages of ML model lifecycle: model development and model registration. Now let's move to next stage, model deployment. The operations team or MLOps engineers then take the model from the registry that we have registered over here in this particular stage, model registration, and handle the deployment process. This step involves putting the model into production, where it starts making prediction on live data. Deployment can be done using APIs, containers, or other applications, depending on the specific requirements and use case. So we have completed three stages of ML model lifecycle: model development, model registration, and model deployment. Now next stage, monitoring and retraining. After deployment, the model's performance is monitored. If there is drift in model performance or changes in data patterns, the model may be retrained or redeployed. So now you can see workflow of how the ML model lifecycle often works in industry. So now in MLflow, models go through different stages to manage their lifecycle effectively. I'm repeating, in MLflow, models go through different stages to manage their lifecycle effectively. Let's discuss this. You can see over here, model lifecycle management with model registry. And here we are going to take this example, water potability prediction. So as I said, in MLflow, models go through different stages to manage their lifecycle effectively. So a model in MLflow can be in one of the following stages at any given time: development, staging, production, and archive. Let's discuss one by one. This is very important. So now let's start with development. So the main goal of model development is to create and refine the model, which we achieved so far using experiment tracking and other techniques, right? Now let's move to next stage of model lifecycle, which is staging, also called as testing phase of the model. Let's take the example of water potability prediction. So the water potability model is first tested with historical data in the staging phase. As I said, this is testing phase. It is registered in MLflow as staging to track its performance and ensure it meets the required standards before moving to production. This is testing phase. So after this particular stage, staging or testing, model moves to the next stage, production. Once the model is validated, the model is deployed in the production phase. It is marked as production in MLflow and used to evaluate real-time water samples. The model's performance is actively monitored to ensure it operates effectively. After production, model may be in archived state, which is when a new model replaces the old one. The previous model is moved to the archived stage. In MLflow, it is kept for historical reference or compliance purposes. Again, that we will discuss shortly. I will show you this all practically. At the end, we can conclude that model registry helps manage and track models throughout their life cycle, ensuring they are reliable, well documented, and properly handled. So these are the model lifecycle stages that you can see over here. As I said earlier many times, we will discuss this all practically. So these are the model stages that you can see over here. Development, staging means testing, production, and archived. Now let's move on. So throughout this video, we have to assume that we are working in collaborative environment. When the stage changes, everyone can see the current stage of the model, whether model is in development phase or in staging phase or in production or in archived stage. Means our team members can see the current stage of the model. So let's move on to the practical part. Let's jump to VS Code. Now we are going to register this base model in the MLflow model registry using a Python script. We also want to include this process in our DVC pipeline as the next stage. In short, we aim to automate the model registration process so that the model will be registered automatically when we execute our created DVC pipeline. In short, we aim to automate the process of model registration process so that the model will be registered automatically when we execute our created DVC pipeline. So let's create a new Python file in the model folder. Let's move to VS Code. Let's right click over here and let's create new Python file with name model_reg.py. Let's select this code. Let's copy this code and let's paste it over here. Let's save our file. So as we just discussed, we are going to register our based model in the MLflow model registry using Python script. So this is our Python script. Using this script, we are going to register our based model into the MLflow model registry. And also we discussed, we want to include this process in our DVC pipeline as our next stage that we are going to discuss shortly. Let's first visit the code of this Python script once. So here we are importing required libraries. And here we are making connection with DexUp. And also we have set tracking URI. We require to change this information. So let's copy this code from our previous file and let's paste it over here. And let's change this experiment name to final_model. You can give any. Let's save our file. And here we load the run ID and model name from our saved JSON file. This one, right? That we are loading here. And here we are fetching run ID from our created JSON file. And we are storing inside this particular variable, run ID. Same here. Here we are fetching model name from our created JSON file and storing inside this particular variable, model_name. Here we are creating an MLflow client. And here we are creating the model URI, which is required to register our model into MLflow model registry, having following syntax: runs, run ID, artifacts, and model name that we are storing in this particular variable, model_URI. And here we are registering our model using this model URI and with our model name that we have fetched here from our run_info.json file. This one, right? Now here we are getting the model version of our registered model. And here we are putting our model into the staging stage. And from client.transition_model_version_stage, we are passing all the informations that we have created above to register our model into MLflow model registry. And we are registering into staging stage. And here we are printing our information on the console. Let's first execute this file. Let's copy path and let's run our script model_register.py. As you can see, currently we are running it independently. Shortly we will add this particular script as our next stage into our DVC pipeline because we want to automate the model registration process so that the model will be registered automatically when we execute our created DVC pipeline. But currently we are running this particular script independently. Currently, there is no any connection between our created DVC pipeline and this particular file, model_register.py. Now you can see we have successfully registered our model into MLflow model registry that you can see over here, created version 1 of the model based model. Let's check on DexUp. Let's reload this page and you can see here our final model. Let's click here, models. You can see over here, we have successfully registered our created model with name based model and version 1. And currently it is inside staging area because in the script we have mentioned that. You can see staging. So now let's move on. As we discussed, we want to include this process in our DVC pipeline as the next stage so that the model will be registered automatically when we execute our created DVC pipeline. You can see we have successfully registered our based model into MLflow model registry with version 1 and currently it is inside staging stage. Let's click over here. You can see currently our model in staging stage. As you know, staging means testing stage. So as we discussed, we want to include this process in our DVC pipeline as the next stage. Means we want to automate the model registration process so that the model will be registered automatically when we execute our DVC pipeline. So let's create a new stage directly inside dvc.yaml file. So it will be executed when we run our DVC pipeline. Let's move to VS Code and let's click on dvc.yaml file. Now you can see just I have added these lines. So these lines of code will register our model into model registry when we run our DVC pipeline that you can see over here. Also, we have to make connections between model evaluation stage and this particular stage that just we have added model registration. So here let's set outs to reports/run_info.json. So the output of our model evaluation stage is this particular file, which is input to our model registration stage that just we have added into dvc.yaml file. So this stage will be automatically executed when we run our DVC pipeline, and this will automate the model registration process. Now let's save our file. Let's clear this. Let's execute our DVC pipeline. We have to wait. It will take some time. Now all done. We have successfully registered our version 2 that you can see over here. Let's check on DexUp. Let's reload this page. You can see over here. As you can see, our version 1, which is in archived because we have created version 2, which is currently in the staging stage. So now our process has become automated. The model will be registered automatically when we run our DVC pipeline. So now let's move on. So as you can see, our model is currently in the staging stage that you can see over here, which means it is in the testing phase. In this stage, the model will be tested by testers. Now let's assume that our model has passed all the stages of testing. We then need to change the stage to production. Let's change it from here and let's put this particular model, our version 2, into production. Currently, we do not have any other model in the production, so this is not required. Let's press OK. You can see currently our version 2, which is our latest version, which is in production. So at this point, we can say that we have completed the machine learning part, this part, because our model is now available in the MLflow model registry. From here, ops part means operations part will begin, right? Hope you understand this, how MLOps works. So as you can see, our model is currently in production. What we are going to do is we will fetch this model, which is currently here in the production in the MLflow model registry, which is running on DexUp, right? So we are going to fetch this model, which is currently in the production, and perform predictions on sample data. So for that, I have created this very simple script that fetches the model, which is currently in the production stage of MLflow, and performs prediction on the test data. Let's select this code. Let's copy this code. Let's create new file with name prediction.py. Let's paste the code over here. Let's save our file. Just we have to change this tracking URI. So let's take it from here. Let's copy this and let's paste it over here. Let's visit this code. So here we are importing necessary libraries. Here we have set tracking URI for MLflow instance which is running on desktop. Here we specify model name, our registered model, based model, right? Here we create an MLflow client to interact with the MLflow server. And here we are getting the latest version of the model which is currently in the production. And here we are fetching the run ID of the latest version which is currently in the production. And here we are constructing logged model string and we are storing inside this particular variable. The string looks like this: runs / run ID and model name, right? That we are printing on the console. After that, we are loading the model using the logged _ model variable, this variable that we have created over here using this function which is available inside MLflow.pyfunc. And this is the function load _ model. So here we are loading the model using this string that we have created over here. Now here I have created pandas data frame for input data for prediction. And here we are making prediction using this log model that you can see over here. Data, this sample data, and we are printing prediction on the console. And also we are doing this all with exception handling that you can see over here. Nothing else. Very simple. So here I have created this simple Python script that fetches the model which is currently in the production here inside MLflow model registry, which is currently running on desktop and performing predictions on test data, right? I hope all of you are clear with how end-to-end machine learning project works with MLflow in industry, right? So now let's open new terminal and let's try to execute this script. Let's right click, let's copy path and let's paste it over here. Now let's execute this script which fetches our model which is currently in production and performs the prediction on our given test data, this one, right? So let's press enter. You can see it is fetching latest version in production too and also fetching the run ID of our based model. And here it is constructing string of logged model. Using this, it will perform the prediction on our test data, this one. You can see our prediction 0. With these values, water is not potable, that you can see over here. So here we are performing prediction using the model which is currently in the production in MLflow model registry. Hope all of you are clear with this. Now let's move on. You can see that we have performed predictions on test data which is inside a pandas data frame. In the same way, we can create a desktop application using tkinter, an API using fast API, or an application using Flask or Streamlit. To keep things simple, I have created a desktop app using tkinter that fetches the model currently in the production in the MLflow model registry and performs predictions on the data provided by user using our created GUI that we have created using tkinter. You can find all of this in my GitHub repository. Let me show you this. Again, let's create new Python file. Let's give GUI.py. Let's select this code. Let's copy this code and let's paste code over here. Let's save our file. Just we have to change this tracking URI. Let's copy this, paste it over here. Save our files. Clear this. And let's execute our applications. Copy path and let's paste it over here. Let's execute our application. As I said, I have created this desktop application using tkinter. You can create API using fast API, or also you can create web application using Flask or Streamlit. You can see using this GUI, user can perform prediction. Please remember here we are fetching our model which is currently in the production in MLflow model registry, which are currently on desktop. Let's perform prediction using this data: 3.7, 4.89, 0.7, 1.31, 7.3. Let's press this prediction. You can see here with these values, water is not potable, right? So user can perform prediction using our created GUI. I hope all of you are clear with how end-to-end machine learning project with MLOps works in industry. Let's visit our flow. You can see we have started with our problem statement, water potability prediction using machine learning, right? And we have prepared different experiments and we identified our best experiment, meaning our best model. Also, we logged everything including experiments using MLflow on desktop, right? Once we found our best model, we have created DVC pipeline. And also we logged everything using MLflow on desktop. At the end, we built our desktop application by fetching the model from the MLflow model registry, means the model which is currently in the production state of MLflow model registry, which is running on desktop, right? So now we can say that we have completed our entire project that you can see over here. I hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.